Hey 8th graders, we are in section 4.4. We're talking about side, 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 and side angle side, which are two ways to prove triangle congruency. Now, let's quickly go over what we've just done. Up until now, we know that there are 6 corresponding parts of congruent triangles. 3 sets of angles, 3 sets of sides. However, we now don't need to know all 6 things in order to prove triangles congruent. There are shortcuts. And actually, that's exactly what this says. You do not need to write all this down, but it says that you prove triangles congruent by showing that all 6 pairs of corresponding parts are congruent. However, there's a property. This property is called the triangle rigidity. It's hard to say it, but you'll get used to it. Triangle rigidity. It gives you a shortcut for proving 2 triangles congruent. It states this: if we have side lengths of a triangle are given, the triangle can only have one shape. And this postulate is called side, side, side. So whenever you prove triangles congruent through side, 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 all you have to write is SSS. So here's what it says. If you have, let's just make this really easy. All it says is this: if you have 2 triangles and you can prove that all 3 sets of sides are congruent, then you automatically know the triangles are congruent. That's it. That's all it says. If the sides are all congruent, then the triangles are congruent. Now let's actually use that as an example to show you why this works. Now this is not a proof, it kind of looks like it, but I just want you to look at this problem and see, what do I know? So look at the picture, don't read any of this yet. I just want to prove that all 3 sets of sides are equal. Now we already know that PQ and PS are congruent. Those segments are congruent. We also know from the picture that QR and segment SR are congruent. We only have one other side left, and that's PR. But segment PR is congruent to itself. And that's a property you've already talked about. And what is it called? It's called the reflexive property. So the reflexive property of congruence states that anything is congruent to itself. And that could be angles, that could be sides. So by side, 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 we have a side here, a set of sides here, and we have a side congruent to itself. Now some people always ask, why do we have to prove that a side is congruent to itself? Because technically, even though this is one side, this is 2 triangles. 2 triangles that share the same side. So you're actually saying that segment PR of one triangle is congruent to the same segment PR of another triangle. So if you actually separated these 2 triangles, segment PR would be 2 different triangles. So this triangle PQR is congruent to triangle PSR because of side, side, side. All right, now this is a vocab word. However, you do not need to write this down. So let me just move that up here. The reason why you don't need to write it down is you're going to use it within your next proof. An included angle is an angle formed by 2 adjacent sides. Angle B is the included angle between sides segment AB and segment BC. So what you're going to notice next is that when we talk about an angle, for example, side angle side, we have to use this side and this side with the included angle, which is between those sides. Now the next one is side angle side. Now this is where we have to be careful. You'll notice that side angle side means 2 sides and an angle. You have to have it in that order. It cannot go angle side side or side side angle. You have to have the sides with the angle that's between them. That's what we just talked about, the included angle. So here's what it says. If you have 2 sides and the included angle of one triangle congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Why? Because of side angle side. Sides are congruent, these sides are congruent, and the included angle is also congruent. Therefore, these triangles are congruent. In this example, we're going to talk about the Statue of Liberty. Engineers actually use the property of triangle rigidity to design the internal support for the Statue of Liberty. Now here is an up-close picture of the internal supports. We have two triangles. You'll notice that we already have one set of sides congruent and another set of sides congruent. So you have two options. You can either prove the third set of sides are congruent, which we don't have enough information for, or an angle somewhere. Now, you can't have any of these angles because they're not included. So can you figure out why the included angles would be congruent? Well, because of vertical angles are congruent, we can say that angle KPN and angle LPM are congruent. Therefore, because of side angle side, and I'm going to mark that in here, here are the angles, because of side angle side, these two triangles are congruent. All right, in example 3, we want to actually prove that these are congruent by using the value of the variable they gave to us, plugging them in, and seeing if everything is equal. So I've changed A because there's a typo in the book. But we want to know if triangle UVW is congruent to triangle YXZ. So I'm just going to plug in 3 to all the sides. We know this side is 3. We know this side would be 4. And we know this side would be 2. If we look, everything does match up. So we have the 3 sides that match up. We have the 4 sides that match up. And we have segments UW and segments YZ that do match up. And so yes, by side, 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 we know that all 3 sides of one triangle are congruent to the next. Therefore, the triangles are congruent. So now in the next one, if I plug in 7, you would actually get the 15 sides, segment DE and segment JG would be congruent. Segments FE and GH would be congruent, and angle E and angle G would also be congruent. So because of side, angle, side, these two triangles would be congruent. Of course, it wouldn't be fun without a proof, so let's do a proof. We want to know if these two triangles, triangle EGF is congruent to triangle HFG. Our given shows that lines L and M are parallel, and segment EG is congruent to segment HF. You'll notice that everything has been already marked on here, so we have to go and figure out something else. So, what can we do? We can either prove side, 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 and I'm going to write it down here, side, 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 or side, angle, side. Now, what do we have so far? We have just the side. That's all we have. So, do you see anything that we can prove congruent? Is there another side? Is there an angle we can prove congruent? Well, they don't tell us that two lines are parallel unless we're going to actually figure out angles based on those parallel sides. So when I look at this, I can see that I have 3 separate transversals. So if you use this transversal here, I could prove that we have alternate interior angles, but this one is not inside a triangle. So let's go back over here. Let's use this transversal, transversal GF. And I have people that still draw 2 separate pictures so it helps them better see what they need to do. If you want to see that those two are congruent because of parallel lines, you can do that. So I'm going to mark these 2 angles congruent. So what are they? They would be angle. Now you have to be careful in how you name this. These 2 triangles are rotated, so you have to follow the same pattern. So if I say angle EGF is congruent to, then I have to follow the same pattern if I rotated it. And that would be angle HFG. And if you actually looked up here, angle EGF would be congruent to angle HFG. It follows the same pattern. And why? Because of the alternate interior angles theorem. So now we have an angle. So we're not using side, side, side right now. We're probably going to use side, angle, side, but we don't have another side. And here's where your little hint comes into play. If we use side, angle, side, I have a side, I have an angle. Well, if the angle is going to be the included angle, the only other side I have to prove on each of these would be GF. But wait a minute. GF is a shared side of both triangles. So I could say segment GF is congruent to segment GF. Why? Because of the reflexive property of congruence. And right now, I have side angle side. So I can now state that triangle EGF is congruent to triangle HFG because of side angle side. If you think you got it, you could be done with the video. But I'm going to do one more proof, just if you want another extra example. All right, here's our example. Our given says that ray QP bisects angle RQS. Segment QR and segment QS are congruent, and we want to prove the triangle is congruent. So right now we have a side. Is there anything you can think of that we can do with the given or anything else? Well, it says that ray QP bisects an angle. So what does it mean when we bisect an angle? Well, if we bisect an angle, that means angle RQP is going to be congruent to angle SQP. Why? Definition of angle bisector. An angle bisector splits something, or splits an angle into two congruent angles. So we know this angle is congruent to this angle. So once again, we have a side and an angle. So is there another side that you see we can prove congruent? Well, we could say side QP, or segment QP is congruent to segment QP. Why? Reflexive property of congruence. And now I have triangle, RQP is congruent to triangle SQP. Why? Because of side angle side. Now, I've had a few people in the past, and I used to do this as well. I used to actually, with a different color, used to mark what I have. And that way, as I'm going through the problem, I know exactly what I'm looking for, or where I need to go, or what else I need to prove.